Welcome back, folks, to Precalculus. Today we are in Chapter 3, Section 4, talking about graphing polynomial functions. Okay, so we're going to actually start off with a review of a previous section and talk about end behavior. So remember that the end behavior is the direction that the end of the graph is pointing. So when we look left to right towards the negative infinity or positive infinity, we determine if it's going up or down. So from a polynomial equation, we're first going to look at the degree, which is the largest exponent, and the leading coefficient, which is the value beside that variable. Okay, so remember that if we have an even degree with a positive leading coefficient, we're going to end up with some kind of U-shaped graph. It may have a little bump in it or whatever. We don't know. If it's an even degree with a negative leading coefficient, it could end up being it is going to be an upside down U-shaped graph. So notice even degree positive, they're both pointing up. Even degree negative, they're both pointing down. They're U-shaped. If it's an odd degree function, we're going to end with a positive leading coefficient. We are going to end up with a forward-facing S. Whereas if the odd degree function has a negative leading coefficient, we're going to end up with some kind of backwards facing S that goes down as it goes right and up as it goes left. Okay, so let's do a quick example here, and then I'm going to turn you loose. You've actually done these examples before, but I challenge you to do them again. I'll do the first one with you, and then I want you guys to do the next two on your own after you pause the video. But remember, to describe end behavior, we are going to start using limit notation. So limit of g of x as x goes to infinity, and the limit of g of x as x goes to negative infinity. Okay, so if we look at g, okay, the degree, the highest exponent here is 7, so it's got to be S-shaped, and the leading coefficient is negative, so we know it's going to be backwards S. So as x goes to infinity, remember limit means height. The height of our function as x goes to infinity, or in layman's terms, what are the y values doing as you go to the right? So as we go to the right, our y values are going down to negative infinity. What are our y values doing in our function as we go to the left? The y values are going up towards infinity. So now pause the video, take a second, and see if you can evaluate both infinite limits for the next two. Okay, now let's talk a little bit about intercepts. So to find the y-intercept of a polynomial, it's as easy as looking at the constant term at the end of the equation. If it's in factored form, you can either FOIL it out, or you can just figure out what the constant term would be. And you do that by set x equal to 0. If it's a y-intercept, it's x coordinate is 0. So to find the x-intercept in factored form, set each factor equal to 0. Essentially applying the zero product property. So if we look at this first example here, being asked what is the y-intercept, look at the constant term, meaning the x is 0, so 0, 0, negative 4. So when x is 0, y is negative 4. Now over here, we got to find the x and y intercept. So to find the x-intercept, we set each factor equal to 0. So we'll go in order. Negative 1, 0 from the first factor. The second factor, 2, 0. The third factor, negative 3, 0. And the last factor, set that equal to 0. Do a little mental math. 5 halves, 0. Those are all your x-intercepts. Our y-intercept, now we could FOIL all this out, or we could just plug in 0 for x. So that's all we're going to do. We've got negative, plug in 0 for x, so we got 1 squared times negative 2 cubed times 3 times negative 5. Just plugging in 0 for all the x's. That's all we're doing. So we got 1 squared is 1, negative 2 cubed is negative 8, times 3 is negative 24, times negative 5 is going to be positive 120 with a negative sign at the beginning. Your y-intercept is 0, negative 120. Awesome. Okay, now let's do a little bit of multiplicity review from the last section. So this is just review again, but recall that multiplicity is the amount of times that a factor shows up, okay, or the exponent on that factor. So if m is odd, then we know that our graph will cross through the x-axis at that point. And if m, or the multiplicity, is even, then the graph will bounce on the x-axis at that point. Just a little bit of review. So now let's give you a second here to pause your video and go through each one of these factors and determine whether the graph would bounce or cross at 2, bounce or cross at negative 3, bounce or cross at negative 4, bounce or cross at 6, bounce or cross at negative 5. Determine whether the function is going to bounce or cross at each one of these x-intercepts. Okay, let's talk a little bit about graphing now. So a little toolbox here for you guys to use. So when graphing a polynomial, first we want to find the zeros or the x-intercepts, whatever you want to call them, and plot them. They go on the x-axis always. Okay, next we want to find the y-intercept and plot it on the y-axis. Okay, remember that's either look at the constant term or plug in 0 for x. Then we want to draw the end behavior. We want to draw the end arrows first so we know how our graph is going to finish at infinity and negative infinity. And lastly, we want to use the multiplicity of each factor to tell us to bounce or cross the x-axis. Okay, so let's do one quick example. I'm going to do the first one, then I'm going to ask you guys to stop the video and do the next two. Okay, and I can answer those questions in class. But first things first, let's find the x-intercepts. Zero product property, negative 4, negative 1, 3. That easy, no work required. Okay, now, second step, find the y-intercept. Plug in 0 for x. So we've got 4 times 1 squared times negative 3. So the y-intercept is going to be negative 12. It's going to be a little bit off the graph. I'm going to go ahead and draw it right there. Okay, next we're going to draw the end behavior of our function. So first we have to figure out what the degree is. The degree is x to the first power, right? You can see that exponent right there. Okay, plus another 2 powers. That's going to be a total of 3. Plus 1 there is 4. So it's a 4th degree polynomial with a positive leading coefficient. This one right here, even positive. So I know that my end behavior, is going to be pointing up here and up there. Okay. Maybe I should have drawn that one a little better. Anyways, here we go. So now we look at our x-intercepts and their multiplicities to determine whether or not our graph is going to bounce across. So at negative 4, odd multiplicity, our graph is going to cross. So that's all I'm going to draw. At negative 1, our graph is going to bounce. Now, we're not going to talk just yet about turning points, but I'm going to let you guys just turn it around and bounce it off negative 1. Has to go through your y-intercept. And now at 3, odd multiplicity. So we are going to cross through. And there you go. There's a finished graph. Okay, we'll worry less about this turning point right now. Worry about it down the road. Okay, but right now the video is over, but you guys need to do these next two before turning in your notes. So I caution you, the one thing that people are going to miss is this right here, this x. It is a 0. It is an x-intercept. If you set it equal to 0, you get x equals 0. That's your one hint. I look forward to helping you guys in class.